The solution to a linear function are all the coordinate points that are on the graph of the function.
Exactly. So when it asks you about a solution, I want you guys to write down this definition. The solution or solutions to a linear function are all the coordinate points that are on the graph of the function. So every single perfect point, and not even perfect point, just every single point on that line is part of the solution of that function. So I'll give you guys about 30 seconds to write down the definition, and then we'll get started with this little problem I have here. Okay. So here's an example of a graph, right? And I want everyone to pick one point on this graph. I want to see how many total points we can all pick out together. So whenever you see a perfect point, shout it out. Let's list a few of them.
1, -3.
1, Good. What else?
-2, 3.
-2, 3. Keep it going.
-3, 5.
-3, 5. Yep.
2, -5.
2, -5. There's more. Keep it going.
3, -7.
3, -7. Yeah.
-5, 9.
-5, yep, 9.
-1,
Four.
0. No, -0, -1.
Good. 0, -1. Juan, what were you going to say?
5, -9.
5,
Four.
4. Yeah, 4, -9.
-1, 1.
-1, 1. I think there's maybe one or two more.
Huh?
There's at least one more.
Negative, no.
-4, 7.
There you
Yeah.
go. Good. Okay. So all of those all of those perfect points, these are all solutions to the linear function. Now there's more though. These are all the perfect points, but if you really think about it, let me give you an example. Let's see. There's
I can say
also
one.
Go for it, Juan.
-4.58.
-4.5, 8. Yeah. Everything in between, right? So -4.5, 8 would be one example. And we're not going to list all of them, but can anyone give me one more example of an imperfect point that's still on the line?
-6, 2.1 or 2.
Let me see. Oh, you said about,
2.5.
yeah, 2.5, -6. Yeah, right there. 2.5, -6. So I'm going to stop there because in reality, there's perfect points, there's imperfect points. Can anyone take a guess how many solutions are on this line?
Infinite.
Infinite, yeah.
Because if you move slightly, you would get another one.
Exactly. All along this entire line, there's a bunch of tiny, 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 tiny little dots all the way up and all the way down, and it goes on forever. So when you talk about what are the solutions, there's infinite solutions. And that's kind of like the definition of a line. A line isn't just think about this. If you had like a microscope, like a really, really, really powerful microscope, and you zoomed in as far as you could possibly zoom in into this line, you wouldn't see a nice connected line. You would see just a ton of tiny, tiny, tiny little dots that all, when you start zooming out, they look like they're connected. And that's what a line really is in reality. Now, that's like really meta. We don't have to really think about it like that far. But the most important thing to remember is that when I ask you what are the solutions to this graph, the solutions are all of the coordinate points, all of the inputs and outputs that make up that line. So when we have this type of thing on a test, or if I'm asking you like in a homework assignment, it's going to look more like this type of question. So this type of question says, select all the points that are solutions that are in the solution graphed below. So I have this linear function over here, and you're really just going to use your eyes and look up close and play a game of match. So which of those coordinate points are on that line? So take a moment. There is more than one.
Can I say?
And if you have one, you can say it, yeah.
I think it's B.
B, 2,
Yeah.
2, 4 is on that line. Okay, anything else?
And C. No, D.
D, 7, 1.
Yes.
That looks good. 7, 1. Are any other of those on the line?
No.
All right, that looks to be it. Yeah, nothing else really matches. And so that's basically, this is like a easy level 1 version. You know, I always start with the easy ones. This would be like a level 1 question on a test where you really, all you have to do is look closely, take a look, see which points are actually on that line. Okay, so do I have any questions on that?
No.
Pretty basic, right? So go ahead and try one on your own really quick. I'll put a poll. Okay, go ahead and vote. Which of those is a solution to the equation represented on the graph? Okay, a couple more minutes or seconds. All right, I'm missing 3 votes. Go ahead and get them in 5, 4, 3, 2, 1. All right, we're a little bit divided. That was a little bit all over the place. So let's check and see what is going on. So I'm going to check every single one of these points, and we're going to see which one is actually on the line. So I see 0, -3. 0, -3. That's down here. Is that on the line?
No.
Nope.
No.
No,
Definitely
miss.
not. 2, 0. That is right here. 2, 0. Is that on the line?
No.
2, 2. That one's right there. Is that on the line?
No.
No. -3, 0. How about that one?
Yes, it's on the line. I got fooled because of the numbers in B and A.
Yeah, so even though this is kind of an easy question, you can't let yourself get fooled by the fact that it's going by 2s, right? So we have to make sure that we're understanding how to read those coordinate points, how to make sure you line them up properly. So at this point, do I have any questions? And let me label all of these. So this is 0, -3. That one was 2, 0, 2, 2, and then -3, 0. Do I have any questions on reading coordinate points and or lining them up properly? Okay. I think I have one more for you guys to try. Oh no. So this is it for level 1. So from here, it's going to get a little bit trickier, okay? So, okay, we've talked about this over and over again. What are 3 ways to represent a function? We have a graph. What else?
An equation.
An equation
A table.
And table.
and a table. Okay, so graphs can be pretty easy. Equations, okay, that's going to step it up a notch. So here's my level 2 question. So I have an equation and I'm still being asked the same question. It's asking me which points are on the graph of that equation. Select all that apply. When it's given to you as an equation, you have to do a little bit of math. So I'm going to show you guys what I'm going to do. I'm going to go all the way down through all the answer choices. And what I'm going to do is I'm going to test each point to see if it works. So let me write down my equation down here. 3 minus 6x plus 2y equals -5. Now, first of all, is that equation in slope-intercept form?
No.
No. Is it in standard
We
form?
No.
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 Is it in any form that we recognize?
No.
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 It's
This equation, go ahead.
an equation to figure out what numbers
Yeah.
go onto the graph.
Yeah, so it's kind of a mess of an equation. It's not in any form that we recognize, but we can still use it because as long as it has an x and a y, you know it's a linear function. It has an x and just a y, we can use it. So let's look at what we're going to do. So I've got this equation. I'm going to plug in this coordinate point. Now the -2, is that my x or my y?
That's your x.
That's x. What about the 10?
That's y.
That's the y, right? So I'm going to plug it straight into my equation. So I have 3 minus 6. I'm going to plug in my x there and my y there. So for x, I plug in -2. And for y, I plug in -10. And what I want to do is I'm going to evaluate this equation. So I'm going to do the math on the left side. And at the end, if this is a solution, if this point is on a graph, then it's going to match. So let's see if it does. I have to do some multiplication, right?
Miss, what do you mean by match?
You'll see. You'll see when I solve it.
It has to equal -5.
Yeah. So, okay, I have to multiply -6 times -2. What's -6 times -2?
12.
12. So this is 3 plus 12. And then 2 times -10.
-20.
-20. I'm going to keep going on the left side. So 3 plus 12 is
15.
15.
18 much.
And 15 minus 20 gives me
-5.
-5.
-5. Okay, so check out what I have here. I got -5 on the left. I have -5 on the right. This is a true statement. -5 equals -5, right?
Miss,
So-
so that's what you mean by the same. So like if you solve
Yeah.
it and it comes out as the same number twice, then that
Mhm.
makes it right.
Exactly. That's exactly what I mean. All right, so you have to do that with every single answer choice. There's no other way around it. You just have to try each one and see if it matches. So I'll do one more with you guys, and then the last 3 I want you guys to try on your own. So I'll leave that up. This was for answer choice A. Now we're going to test answer choice B. I'm going to do the same thing. I'm going to plug in the x value. I'm going to plug in the y value and then see what happens. So here I'm plugging in -1 for x and +1 for y. And now we do the math. -6 times -1,
Six.
+6. 2 times 1, we know that's 2,
Two.
equals -5. 3 plus 6,
9,
9. 9 plus 2,
11.
11. Does 11 equal -5?
No.
No. That is a false statement, so answer choice B is not correct. So there you go. So that's kind of how it goes. So I want you guys to try now, plug in the numbers for answer choices C through E, and we'll meet back in about 5 minutes and see if we agree on our answers. If you have any questions, feel free to ask. We're still learning, so I'm happy to answer any questions right now. Okay, a little bit less than 2 minutes remaining.
Does she hear us? Ms. Lopez, can you hear us?
Yes, I can hear you now. What's going on in there? I only have 2 of you guys are signed on. Only Guillermo and Christopher are signed in right now. What's going on?
Oh, signed in.
You guys just missed out on about 20 minutes of learning, and I'm not going back. All right, that's time, guys. So I see a
Liz,
couple.
did you put the poll out?
Oh, I'm not putting up a poll yet because I want to go through it together, but I'll do a poll on the next slide.
Okay.
But you can send me your answers. Whatever you got, send it in the chat. I'll tell you. Well, let's start going through it. So I want you guys to tell me exactly what you get each time, okay? So we'll go through it together. And I want to hear from you.
When you got to sit in the middle.
For C,
Get up and sit in the middle. Where?
0,4.
What's your percentage on?
It's on 5.
What's yours on?
For C, what am I plugging in next to the 6?
Mine's on 32.
0.
0. And then on the other one?
4.
4.
All right, here we go. I do my math. 6 times 0?
0.
0. So 3 plus 0 plus 2 times 4 is
8.
8. 0 plus 8, or 3 plus 8, I mean?
11.
11.
3.
So does that work out for us?
Nope.
Nope. C is out.
Miss, I got the same answer, but can you tell me
Mhm.
how you got the 3 plus 0? Because I got 3 minus 0. Me too.
Oh, yeah, that should technically be a minus. I'm sorry, but either way, it's the same.
It doesn't do
Okay.
anything.
Okay.
Okay. So C is out. Now let's try D. So for D, I have 3 minus 6 times x plus 2 times y equals -5. What do I plug in here?
You plug in 4
Mhm.
and then
4
8.
and 8. Awesome. All right, my math here. 3, what do I got? What do I write in the next step?
You're right. Minus 24
Minus 24.
and then plus 16
Good. Plus 16.
equals -5.
Cool. All right. And then what is 3 minus 24?
-21.
Okay. And then -21 plus 16?
-5.
That is -5. Good. So this one involved a lot of math with negatives. All right. So you had to be pretty careful in doing that math. In the end, this one does work out. So 4,8 is correct. Questions on that one? Because I know there were a few negatives, so I just want to make sure that we understand. Awesome.
Hey, what about the last?
What? I didn't hear that.
The last one.
Oh, the last one. Yeah, let's do the last one. Okay, so this one I'm plugging in 6 and 14. All right, what do I get in the next line?
You get 3 minus 36
3 minus 36
plus 28.
plus 28. Good. All right, 3 minus 36.
Discussion. Everybody pay attention.
-33.
-33. Good.
Let me know. It's your responsibility. It's a 2-cent roll before school over. Get school out.
-33 plus 28.
-5.
-5.
Good. Awesome. That one works out as well. So there you go. A, D, and E. Do I have any questions on the process of how you do this when it's mathematical, purely mathematical?
No.
Any questions? RL feels
Wait,
good.
Miss, I do have a question.
Yes, what's up?
Like, does it, like, are you always gonna do this no matter like what the equation is?
Mm-hmm. Always, yeah. If it, I mean, obviously you got to read the question, right? But if the question is asking you which of these is on the graph or which of these is a solution, those are your keywords. Solution. That's the process. That's what it's asking you to do. It's asking you to test each number and make sure that it works out correctly, no matter what the equation looks like. So in fact, we're going to do a couple more examples. So let's take a look at a different equation. So the graph of the equation 2x plus 6y equals 4 passes through point x comma negative 2. What is the value of x?
You gotta pay attention. That was
Okay, so in this case, it looks like I know which of the values do I know from this point.
Why?
I know, yeah, I know the y value, but I don't know the x value, right? So it's it's a similar question, but it's actually a little bit easier because in this case, I have my equation. And by the way, what type of equation is this written in? What kind of form?
Points.
Standard.
This one is standard form. Yeah, good job.
Okay.
Standard. Remember that point slopage error? That one has the parentheses. So this is so this is standard form. I'm going to plug in the y value, and the question is asking what is the value of x, right? So I'm plugging in the y value, and then I'm going to figure out by doing the math what is going to be the value of x. So here I have 2x plus 6 times negative 2 equals 4. All right. And so that's just going to be, now I do the math from here. So 6 times negative 2, what is that?
Negative 12.
Negative 12. So 2x minus 12 equals 4. I want you guys to go from here and see what you get for the value of x.
We need x by itself, right?
Exactly, yeah. Okay, Guillermo in the chat is telling me I gotta add 12. That is true. I want you to do it on your own though. So I'm waiting for everyone to kind of try it out by themselves, and then I'll ask for how to do it. And let me see you trying. Amani, let me see you writing. You got an answer?
These two girls are actually not paying attention. That's why I can't call them. They both of them not paying attention. Jeffrey don't have a laptop. Here. You can't do that. You come to school. Your school start at 9 o'clock. You gotta wake up early and eat breakfast. Them two are not paying attention. Come on, Jeffrey. No, you're not. He probably gonna call home. Jeffrey. And from now on, you guys do not sit next to each other at all. No, that's why I just had to move. Sorry, they were right next to each other. Jeffrey don't have a laptop. Jeffrey, he said this person laptop can't come. Did you see on the screen? I don't care. Why you get a laptop for? No, I'm just saying, like, he's not, it's on the screen, but he don't have no paper, pen, just chill. You have a picture with his advanced class, man? Obviously, you don't belong. Only one that's pretty much paying attention to you. That's all. No, I didn't really look at that.
Mr. St. Rose, can you hear me?
Yeah.
Okay, I'd like to have a conversation about those students after class, if that's okay
Okay.
with you. Okay.
I'm gonna take
Because
a
because this is not the first time that this keeps happening, and we need to do something about it. So I'd rather not waste class time because I have a lot of students over at home especially, and I also have Christopher and Guillermo who are on point all of class, and I'm not about to let them fall behind because I have a handful of students who don't want to behave today.
What's your next part?
All right, so I'm seeing a lot of correct answers in the chat. So who would like to tell me what I need to do first?
Add 12 to both sides.
Add 12 to both sides. Awesome. 4 plus 12, what's that?
16
16. Now I take both sides and I do what?
divided by 2.
And my final answer is x equals
8.
awesome.
Jeffrey,
All right, so to answer what RL was asking earlier, there's kind of two different questions it might ask you. It might ask you which of these is a solution. So in this case, you have to plug in the x and the y and then check to see if it works, right? But it might also ask you, okay, here's the value of x, figure out the value of y. Or it might go the other way. It might say, here's the value of y, figure out the value of x. And you have to plug in one of those numbers and see what you get on the other side. So do I have any questions about the different strategies that we're using? I have a couple of practice problems, okay? So here's one example. So I want you guys to think, would this be strategy number 1 or strategy number 2? Guillermo said it correctly in the chat. So that's going to be strategy number 1. I have to take all of these answer choices, each one, and test it out. So I need to plug in the x and the y and then see if it gets the same number on both sides. All right, so I do have a fraction here. Would you guys like me to try this one with you first, or do you think you guys can handle it with the fraction?
You could do this one with us.
You want me to do it? Okay, I'll plug in example A, just example A, and then the rest you guys try it on your own. So for A, what am I plugging in for y?
-3.
3, negative
Negative 3 goes in for y, and then for x, what do I plug in?
0.
0. Oh, see, I picked an easy one. Okay, well, even though that's a 0, if it was another number other than 0, how do I multiply that with the fraction?
Yeah, Miss, can you explain that? Because I get confused.
Okay, here, matter of fact, let me not do, I'll do example C. How's that sound? That way I have 2 whole numbers. So I'll do example C. I plug in a 2 for y and a 2 for x. So I have this fraction, right? Can anybody explain to me and to RL, how do I multiply that fraction times the whole number?
You get
Multiply everything by 3.
Okay.
The outside. by
Everything by 2?
Okay. Okay, let's think about what we're actually doing here though. So I heard that you have to multiply everything by 3, but that's when you're trying to solve like an equation for x. Here, we're just trying to evaluate the right side. We're trying to solve the right side so that we can get an answer and see if it matches. So I'm not going to try to eliminate the fraction. I have to actually multiply with it. So how do I multiply 2/3 times 2?
Miss,
Multiply
like,
the
do you
numerator?
like give it like 1 as a denominator and then cross multiply?
Yeah, you
Is
can do
that
that. So 2/3 times 2 over 1.
Oh, right.
And then you multiply straight across. So that's 2 times 2, and then that's the numerator, 2 times 2, and then the denominator would be 3 times 1. So this would be 2 times 2 is 4, 3 times 1 is 3. You see what I mean? See what I did there?
Yeah.
That's exactly what we do. The other way that I always say, you can also multiply the whole number by the numerator, and then divide it by the denominator. But in this case, since 2 times 2 is 4, you can't really divide that by 3 to get a whole number, so we just leave it. So it's 4 over 3. But now I have to add. I have to add 2. How do I add a fraction with a whole number?
You turn the whole number into a fraction.
You have to turn the whole number into a fraction. So for example, okay, what if I did this? 4/3 plus 2 over 1. Can I just add those two?
No,
No, why?
because that's not the proper way. Like it has to be a denominator of 3.
It has to have, exactly, they have to have matching denominators. So in order to get the 2 over 1 to match, what should I multiply it by on the top and the bottom?
You have to multiply the 2 times the number, the denominator.
Right. So in other words, and I think I see Guillermo said it privately in the chat as well, we're going to multiply the numerator and the denominator by 3. Because I'm just multiplying it by 1 because 3 over 3 is 1, but it's like a little bit of a cheat. I'm cheating a little bit. I'm multiplying the top and the bottom by 3 because now I get 6 over 3. I haven't changed the number. I'm writing it in a different way. And now I can add. So what's 4 plus 6?
10.
10. Yeah, so this is 10/3. Does 2 equal 10 over 3?
No.
No. So answer choice C is out. Now the rest of these answer choices all have zeros in them, so I left the easy ones for you to do. I was nice and I did the hard one. But try it out. Take your time. If you have to multiply a fraction by a whole number, go back to this example. I'm leaving it up. And just make sure you're following the same steps. I'll put 5 minutes on the timer.
You said do the rest?
Yeah, so we still don't know which one's the right answer. So you have to test all the other answer choices until you figure it out. About halfway through, 2.5 minutes left.
Come in. Why you late? You just got to sit? Sit around, stop looking. You are tripping. for real. We gotta call home. You are really tripping. No, you're very tripping. For real. They gotta call home. You're not messing up everybody's vibes. Don't pay attention now. Just do what you gotta do.
About 30 seconds left. All right. All right, guys. So I have a few correct answers in the chat. What I'm going to do is I'm going to show you guys one correct answer and one incorrect answer. And that'll be it. So can anyone choose for me an incorrect answer to show?
A.
A. Good. I was hoping you'd pick A. So I'm going to show you why A is incorrect really quick so we can see the difference. So for A, I would plug in a 0 for X and a -3 for Y. And if I plug in a 0 for X, and when I do the multiplication, 2/3 times 0 is
0.
0.
0. That's just 0 because 0 over 3, any way you try it, it's still going to cancel out to 0. So that's 0 plus 2, which is 2. So -3 is not equal to +2. Okay? So for A, you have to make sure that you plug things into the correct place. Because A is very similar to which other answer choice?
D.
D, right? Now for D, let's see what happens. For D, it's kind of switched, right? So the Y is going to be 0. And then the X is going to be -3. And now let's see if that works. So here I have to do a little bit of math. What is 2/3 times -3?
-6 over 3.
Yeah, so if you kind of do it, if you do it step by step, this would be 2/3 times -3 over 1. On the numerator, 2 times -3 is -6. The denominator is 3. And what's -6 divided by 3?
-2.
-2. So this is -2 plus 2. And what's -2 plus 2?
0.
0. So that one is the only one that works out.
Miss, but like, how come like the Y can be replaced, but isn't it not supposed to be replaced?
In this kind of in this question, we had to replace the X and the Y because we have to try each and every coordinate point and see if it works out. So I had to replace the X and the Y and then see if you got the same answer.
Okay.
Any other questions? I have one more for you guys to try, and it does have more fractions. So I wanted today to be kind of like a chance to practice fractions too, because they do come up. So do I have any final questions on this one?
Can you explain the second step again?
Explain which step?
Second one.
The second step, yeah. So I'm multiplying this fraction by the whole number. Anytime you multiply a fraction by a whole number, you have to multiply it. You can, okay, so I did this kind of one way. There's two ways to do it. You can either split it up. Okay, so my whole number, I just made it into a fraction by putting it over 1. And then you just multiply the numerators together and the denominators together. So I did 2 times -3, which was -6, and then 3 times 1, which was 3. Now that's one way to do it. Another way you could have done it is to multiply it by the numerator. So you multiply the whole number by the numerator. What is -3 times 2?
-6.
And then you can divide by the denominator. So what's -6 divided by 3?
Divided by 2.
-2.
-2.
Yeah. We got the same answer doing it both ways. So there's two ways to do it, but at the end of the day, it's still the same process. You're multiplying the numerator by the numerator and then the denominator by the denominator, and then you divide because fractions are division. A fraction is a division problem. Numerator divided by the denominator. Let's do one more. It's got fractions, lots of fractions. So we're going to do a lot of fraction practice. We're going to do this one together because I do want to make sure that I clear up any more confusions you guys might have about fractions. Okay, so I have this equation and I need to select all the points that are solutions. So which strategy am I doing? What am I doing over and over again?
Checking all of them.
Checking each and every point, plugging in the X, plugging in the Y, see what you get. So let's go right through it. Starting with answer choice A, we're going to plug this one in. What do I plug in for Y?
1/2.
1/2 for Y. And then X
0.
is 0. This one's kind of easy. It's a lot of fractions, but this one ends up being kind of easy because what happens?
It doesn't
Because it
equal
becomes
because
0.
It becomes 0. Yeah, 1/2 times 0 becomes 0. So now I'm left with 1/2 equals 0 plus 3 over 4. What's 0 plus 3 over 4?
3 over 4.
4.
Yeah, it's 3/4. Does 1/2 equal 3/4?
No.
No.
No. So that one's automatically out. Let's check the second one. Now I'm plugging in 0, 3/4. What do I plug in for Y?
3/4.
3/4. For X, I plug in 0. And the same thing happens. What happens here?
0 plus 3/4.
0 plus 3/4. Well, again, oops. 0 plus 3/4 gives me 3/4. And what happens here? Does this one work out?
Yes.
Yeah, this one works. So far, not too much math involved, but I think in the next one, we're going to have to do a little bit of math. So how are we so far? Any questions so far? Okay. Going right along with it, answer choice C. I plug it right in. So I have, what do I plug in for Y?
0.
0.
So 0 equals 1/2 times 3/4 plus 3/4. What is, now we're multiplying these two fractions. So 1/2 times 3/4. Remember, I multiply numerator times numerator, denominator times denominator. So what do I get?
8/3.
3/8.
I mean 3/8.
Yeah.
3/8.
3/8. Okay, now from here, I can already tell these are not going to add up to equal 0 because that would not be possible, but I still want to practice how you would add these together. So again, if I need to add two fractions, what needs to match?
The
The
denominator.
denominators.
The denominators. So which of these fractions can I change so that it has the same denominator?
3/4.
3/4.
Yeah, what should I multiply 3/4 by to turn it
2.
2? So 2/2. Okay, so this is 3/8 plus what?
6.
Yeah,
6/8.
6/8, good. And what is 3/8 plus 6/8?
9/8.
9/8, good. And obviously, yeah, 0 does not equal 9/8. So that one's out. Am I going too fast? Anyone have a question on how I did any of those calculations with my fractions?
Why did you get 2/2? Why did you multiply 2/2?
All right, who can explain? Why did I do this? Why did I multiply by 2/2?
Because you couldn't add 3/8 because they didn't have the same denominator.
Right. You couldn't add them before because one had a denominator of 8, the other one had a denominator of 4. So we multiplied it by 2/2 in order for the denominators to match up. Now they're both 8. Now we can add. So you always have to think of what number can I multiply it by in order for them to match.
Miss, are they ever gonna give us like a number we can't multiply it by? Like they won't ever equal?
No, you can always find a number that they'll be able to equal. Sometimes you might have to multiply both of them though. And maybe we'll get an example of that here, but let's move on to the next one and see if that happens. Because here there's a lot of fractions, right? So now what am I plugging in for y for answer choice D?
1/2.
1/2 goes in for y. And then 3/4 goes in for x. So we're kind of doing the same thing that we just did, right?
Yes.
Okay, so we already know that this is going to be 3/8. We already know, because we just did it, that this, when you add it correctly, will add up to 9/8. So does this one match?
No.
No. Okay. So last one. Now for y, I'm plugging in 1. And for x, I'm plugging in 1/2. All right. What is 1/2 times 1/2?
1/4.
1/4, good. Can I add these up?
Yes.
Yeah, what's 1/4 plus 3/4?
1.
Right, because if you add it up, you get 4/4, but I know that 4/4 is the same as 1. So we got an answer. This one's correct, and we're good. Now I want to answer the question I heard before, which is, will you ever have two numbers that you can't match up? So here's an example. What if you had, this is not part of the problem, this is just a little extra fraction practice. What if you had to do 2/3 plus 3/4? Can't really add those, can I?
So we're gonna have to multiply both by 3 or 4 to
Yes.
make it equal 12.
Right. So instead of only, you can't just multiply one, you have to multiply both fractions by something. So 2/3, I can multiply that one by, you said by 4, right?
Yes.
Yeah, so this one gets to be multiplied by 4/4, and then the other one can be multiplied by
3/3.
3/3.
3/3. Because now I end up with 8 over 12
All right.
plus 9 over 12. So the denominator turns out to be, does anyone know what that's called? This number? Between the 3 and the 4, this is the
Well,
Least
L,
common denominator.
Yeah, LCM.
least common multiple.
the least common multiple, yeah, and the least common denominator. But in either case, we were finding the LCM of 3 and 4, the least common multiple. And then using those numbers to multiply, and then that way you end up with the same denominator. So that's kind of an example of where you have to change both fractions in order to get the same denominator. So any questions on that? Any questions on any of the fractions, any of the operations we did with those fractions? I just want to make sure that I'm crystal clear. All right. Okay, so now okay, so let's kind of like review because we've been doing a lot. We started off with very easy problems, right? Where you just look for the coordinate points that are located on the line, and those are your answers. Same thing here, we looked for the coordinate point that was on the line, and that was our answer. Then we realized that we could also do it mathematically. We did that a few times, quite a few times with our fractions. And now we're going to put it all together. So let's take a look. This seems to be a pretty easy question, right? It's asking, okay, which of these are the solutions to the graph? Select 3 that apply. So I want you guys to start this problem and then let me know if you run into any issues.
I see the first one is out of the point.
Yeah, the first one is out of the box. It's going to be somewhere in this region over on the left, but we can't see it, right? Are there any more that you can't really see? E, right?
D and E.
21,8, that's going to be somewhere out over here in space. Can't really see that one. Same with D. D is going to be a little bit off on the right side. So they're out of the box. So when you get a problem like this, we have to do a couple of steps. Okay, so this is one of those like multi-step situations, and we got to be very, very organized with it. So I have a line on a graph. I can see some of the solutions, but at one, yes, Juan.
Actually, yeah, continue. I'll say that.
Okay. So we can see some of those answer choices, but most of them are located outside of the box of the graph. But does that mean that the line stops there, or does the line keep going?
I keep going.
Yeah, these arrows tell me that this line keeps going on and on and on forever in this direction and in the other direction. So even though we can't see those points in front of us, there is a way to figure out if they belong to this line. So what we're going to do, step 1, is we are going to write an equation for the line. And we know how to do this because we've been doing it for a couple of weeks now. In order to write an equation for this line, what are the 2 values I need to figure out?
The slope and the y-intercept.
Good, the slope and the y-intercept. So I want you guys to see if you can do that on your own. We haven't done it in a couple of days, but I know you know how to do it. Take a look at this line, figure out the slope, and figure out the y-intercept. I'll give you guys about 2 minutes.
Oh wait, Miss Lopez.
Mm-hmm.
I forgot. What point do we start on?
Any 2 perfect points.
No, but what line? Is it X or Y?
X comma Y.
Oh, okay.
Miss,
Sorry.
but I wanted to say that B and C, not
B and C are in the, okay, yeah, so you're
in the
right.
line.
We'll go through that after when we're doing all of them. But for now, let's just focus on this step. So we're writing an equation.
Miss B is the y-intercept, right?
Yes.
Okay.
Just find the slope and the y-intercept right now. All right, that's time. What is my slope?
2 over
1 over 3.
2 over 6, which equals
1 over 3.
3.
1 over 3. Careful.
Oh.
2 over 6. Simplified as a fraction, that's 1 over 3. Slope is 1 over 3. What is the y-intercept?
1.
0, 1.
0, 1. So I'm just going to write 1. Okay, so then what's the y equals mx plus b equation, slope-intercept equation?
Y equals 1/3 x plus 1.
Perfect. All right, so now I have an equation, right? And remember, we know what to do with an equation. We know that with an equation, you can just plug in the values and figure out if they work out. So even though I don't see those numbers on the graph in front of me, some of them I do, but most of them are outside of the graph. Those that are outside, you can use the equation instead. So that's why I kind of hinted at this all along, but with algebra, there's the visual aspect and there's the algebra like math aspect. They go hand in hand and you have to be able to do both. So before I go through it, a couple of you guys mentioned that there are some points in this list that I can see. So let's look at the ones that I can see first. Which ones can I see and determine?
Miss, you can see B.
B. Okay, so is B on this line?
Yes.
Yes, -6, 1. That's right here.
C.
Oh, yeah. No, that one is not.
I read that as -1. I don't know.
Yeah.
How about C, Miss?
C.
How about C? Let's see. 3,
C
2.
works.
Yeah.
3, 2 does work. So that one is good. But the rest, they're outside of the graph, so that's where the equation comes in.
So we will have to plug it in with the X value and Y.
Yes, exactly. So go ahead now, take another 5 minutes, plug in the X and the Y, and see if they work out for A, D, and E. 5 minutes, start now. Okay, about 2 minutes left. Okay, about a minute. Three, two, one, time. All right. Who would like to give me one answer that is correct? And I'll go through it real quick.
A.
All right, good. A is correct. Let's check it out. I've got a fraction, so we will be a little bit careful, but you guys can handle fractions. We've been doing really well so far. Okay, so -4 goes in for y, -15 goes in for x, and when I multiply -15 times 1/3, what happens? What do you get?
You get negative
Negative
negative 15/3.
-15/3. And then -15 divided by 3, what's that?
5.
-5.
Good, -5. All right, and then -5 plus 1
-4.
is -4. So that one works out.
Oh, that's why.
Did you get -6?
Yeah.
Yeah, so you got to be careful with that. We were adding 1, so you got to go backwards, right? So because we're negative, we go backwards. Okay.
Simple mistake.
Little mistake, yeah, those happen. Okay, next up. What's another one that is correct?
E.
E.
E is correct. Good, let's check it out. Okay, so for E, I'm plugging in
You plug it
21,
in
21 and 8.
21
So,
for X, and then 8 for Y.
Okay, perfect. So here we go. 21 times 1/3.
21/3.
21/3,
7.
which is 7. 7 plus 1?
8.
8. Good. That one was almost easier because there were no negatives. Questions on those 3?
Nope.
Would anyone like me to show why D is incorrect? Going once. I'll show it. Okay, yes, I got one yes. All right. So for D, 9 goes in for Y, 12 goes in for X, and 12 times 1/3, what do I get there?
4.
Yeah,
4.
right, because this is 12/3. 12 divided by 3 is 4. So this is 4 plus 1, but that would be 5. That's wrong. All right, so this is a really good, see, we're blending two things together. On the one hand, you can find things on the graph, but on the other hand, we have to also use some algebra to figure it out. So I have one more problem. I think we have enough time. It's very similar. So first start by looking, are there any of these that we can at least identify on the graph?
It could the 10 and wait.
Mhm. You're on the right track, Ajara.
No, is that I was confused
I
because
should ask which ones we can see on the graph.
Yes. So which of these are in the box and you can actually see?
I think this A.
A, right? 10, comma 2.
Yeah.
10, comma 2 is right here.
It's off.
It's just a little bit off. So A, we already know that's out. What about B? Can you kind of check B?
Yes.
Yeah, if you go to B, -1, comma -16,
No, it doesn't actually.
it's
It
like
doesn't.
right, yeah. It's right under.
C, you
that
can't
one-
even see.
And then D, -8, comma -25, we can't be so sure because that's off the graph. And then C is also off the graph. So notice, visually, we can already eliminate 2 answer choices. All right. So now we can use the other strategy to figure out between C and D, which one's going to be correct. Okay, so first up, what do I need to do?
Find the
Mm,
slope
find the
and the
slope.
y.
And the
Yeah.
y.
Good, we're going to write the equation, so we need to find the slope and y-intercept. So go ahead and start that.
can we do rate of change?
Yeah, you can use the formula. Nice. Lauren has it in the chat already, and I'm going to move a little bit quick because we are running low on time. If you use the formula or if you do rise over run, either way, you should get 3/2 for the slope. So the slope is 3/2. What about the y-intercept? They actually give you that one. So what is it?
-13.5.
-13.5. So we're going to keep this all. I know there's fractions and decimals. This is going to be a fun one, right? So this is y equals 3/2 x minus 13.5. Love that for us. And now let's go ahead and start plugging things in. So the nice thing is if you check one and it's wrong, then the other one is right. So we only really have to do this one time. So I'm going to plug in 12 for y and 17 for x. If I'm correct, I believe this question was on the calculator portion of the test. So you could use a calculator because this is going to be a little bit tricky. But what do I get? 3 times 17. What is that?
51.
51.
51. So this is 51/2. And you can use your calculator. What is 51 divided by 2?
25.5.
25.5 minus 13.5. What do I get?
12.
Does that add up?
Yes.
It sure does. There's my answer. And you could obviously on a test, I would definitely recommend checking answer choice D to make sure it's wrong. But right now we're a little bit out of time. So there you go. That is pretty much it for today. I know I had some more, but we're going to do these tomorrow. I have a good review day planned for us tomorrow. But do I have any final questions before I let you guys
Be
go?
forgetting to divide it. Like I forgot. I just subtracted. Like when it's 51,
Mhm.
so I should have divided.
Oh, you
They're
didn't divide
saying it-
this?
No, that's why I'm getting it wrong.
Oh, okay. So remember, fractions are division problems, always. Any fraction you see, it's technically a division problem because the bar, the fraction bar, is a dividing bar. It's like 3 divided by 2, 1 divided by 2. Any fraction is secretly a division problem. All right. So to answer someone's question, yes, there is homework. Remember that I extended your homework that was supposed to be due, yesterday. I extended it to make it due Friday, tomorrow. So it's due tomorrow at midnight. And there will be a quiz tomorrow as usual. So make sure that you're studying everything that we went over this week. If you missed class or missed a portion of a class, go back and watch. I've been uploading every single video. So that is your responsibility to make sure you catch up with anything you missed out on. All right, y'all. So this is it. Have a good rest of your days, and I will see you tomorrow.
Bye.
Bye, everyone.
Nice day.
Thank you. You too, Ajara.
Ms. Lopez,
Yes.
do you have a third period?
No, I have common planning now.